What's up, guys? So we're going to do a video real quick on a couple different types of solving logarithmic equations. And I can't show you all the different examples, but what I can do is show you a few tools, enough examples to give you the basic tools to solve these equations. So if you look at the top of your homework 11 worksheet, you probably have a couple examples like what I'm going to show you first. So here you've got a logarithm on both sides with a common base. Anytime this happens, the only way these can be equal to each other is if what's on the inside of the logarithm is also equal, which means we can really disregard the outside completely and just set the insides equal to each other, which really gives you a simple linear equation. I can subtract 3x from both sides, subtract the 1 from both sides, and get x equals 5. Another type of example, which is on the top of your worksheet, is the type of example where you have a logarithm on one side and just a number on the other side. In other words, you don't have a logarithm on both sides. To get the x out from inside of the logarithm, in this case, what we want to do is rewrite it as an exponential function, or an exponential equation. So I'm going to rewrite this as 3 to the third power equals 2x plus 1. Well, 3 to the third power is actually just 27. And so now I can solve this, again, like a linear equation that it is. So subtract 1 gives me 26, and 26 divided by 2 is 13. Problem with writing in marker is it's kind of hard to erase. Okay, and another type of example I want to show you is when you start applying the logarithm rules we learned about recently. So here we have a problem where you can clearly see that what we're going to use, since we have a common logarithm here, we can actually combine these into one logarithm using the product rule, which means we need to multiply what's on the inside. And since this is two terms, we need to distribute. So what we're going to get is log base 2 of, now on the inside, x times x is x squared, x times 2 is 2x equals 3. All right, and so now I'm going to rewrite this to get the x out from inside the logarithm, rewrite it as an exponential equation. 2 to the third power equals everything on the inside. Well, 2 to the third power is actually just 8. And so now I need to move the 8 to the other side by subtraction. And that's because I now have a quadratic that I want to set equal to 0. You can use the quadratic formula at this point, or you can try to factor. In this case, since it's easily factorable, I'm going to go ahead and do that. X plus 4 and x minus 2, which means my solutions are 4 and 2. Now, even though it says we have two solutions, we probably don't. So we need to check and make sure that both of these are actually solutions. Okay, so when we check, first thing I'm going to do is plug the 4 in. Everywhere I see an x, I'm going to plug in the 4. And let's see what we get. All right, so log base 2 of, all right, if we did 4 plus 2, that's 6. And we plug in the 4 here. Okay, now log base 2 of 6, I don't know what that is off the top of my head, but it's going to be a little more than 2, right? Because 2 squared would be 4, so it's got to be a little bit more than 2. But this I do know. This has to be 2, right? So even if we don't rewrite this part has to be 2, okay? Now we're saying something plus 2 equals 3. That means this has to be 1. But 2 to the first power is not 6, so there's no way this works. If you want to, you can use the change of base formula and actually figure out what these are and see if it works. But you can tell that it's not going to be possible, okay? You could do in your calculator log of 6 divided by log of 2 and see what you get, and it would be 2 point something. Now if we plug in the 2, you're going to get a 4 in the first parentheses and a 2 in the second parentheses. So what is log base 2 of 4? That's going to be 2, and log base 2 of 2 is 1. Does 2 plus 1 equal 3? Yes. So that is a solution. So what that means is, going back to our answers over here, these were the answers we had. Okay, not both of these are actually going to be solutions. The 4 is not really a solution, so I'm going to cross that one out. Only the 2 is. Okay, and just do a couple more examples here. This is actually a form of logarithmic equation. It doesn't seem like it right now, but we're going to have to rewrite this problem as a logarithm in order to solve it. When you've got something like 4 to the x equals 7, there's no whole number that you can raise 4 to. It's going to give you 7. So in other words, 4 to the first power is 4. 4 to the second power is 16. Well, 7 is somewhere in between those. So what we have to do is raise 4 to some kind of fraction power, some kind of decimal. We don't know what that is. So the way we're going to get this x out of the exponent, we're going to rewrite this as a logarithm. Remember, we've been sometimes rewriting as exponents, sometimes rewriting as logarithms. Basically, do whatever you need to do in order to get the x out of either an exponent or out of the logarithm. So in this case, by rewriting this as a logarithm, I can say log base 4. Remember, the base stays the same, and the other two kind of switch. Log base 4 of 7 equals x, like this. Log base 4 of 7 equals x. Well, now the x is out of the exponent, and it's by itself. And so what is that? We can put in our calculator this by using the change of base formula. One place where we're going to be using that. So the change of base formula would say log 7 divided by log 4. You could just put that in your calculator and get 1.4. And again, this makes sense because 4 to the first power is 4, 4 to the second power is 16. We need something in the middle, and 1.4 is that number. 4 to the 1.4 power is 7. Another example, and this is really solving an exponential equation, but kind of like the last one, but the difference on this one is on both sides you have x in an exponent. So we can't just rewrite this as a logarithm in order to solve it. What we need to do is solve the exponential equation by noticing that both sides can be written with a common base. 8 and 16 are both some number to a power, and the number that you can rewrite both of those as is 2. 8 is 2 to the third power, and 16 is 2 to the fourth power. When you have a problem like this, you're going to really be hoping that you can rewrite both sides as some kind of common base. So if this is 2 to the third and this is 2 to the fourth, I can just replace those with those numbers. 8 is just 2 to the third, 16 is just 2 to the fourth, and I use them in parentheses with the exponents they had before still outside. Now I just need to distribute. So 2 to the third to the 2x power means I've got to multiply those exponents together and get 6x. And here I've got to actually distribute this 4 across both of those terms like this. Now that I have a common base on both sides, it allows me to set the exponents equal to each other. My running joke is that these are called dubstep problems because you're really just waiting for the base to drop. Now that we drop the base, we can say that the exponents are equal to each other. And so I want to subtract 4 from both sides, and then I can divide both sides by 2, and x equals 2.